Hello friends, welcome to my YouTube channel. Today in this video I am going to show you some interesting calculations involving matrices in LaTeX. Friends, I was one among those who believed till date that LaTeX was only a typing software, typing thesis and research papers and articles, books, etc. But then I came across a package called calculator recently, with which one can do a lot of calculations using LaTeX. In this video, we focus primarily on some matrix operations. This video is going to be very useful for those who want to make a short answer type question paper or problem set involving small matrices, in which the answers of the questions get modified automatically whenever the matrix elements are modified. You don't have to actually calculate the answers. LaTeX will do that. But one thing, all the matrices must have at most 3 rows and at most 3 columns. This documentation of calculator package is available in the internet freely. You can download it and you can read it. Some pages relevant pages in fact from this document I have displayed here. For example, in this page you see there is a command called vector copy for 2 element vector, and this is a vector copy command for 3 element vector. So these 2 vectors, if you want to write, then you have to write this much command, vector copy 1 comma minus 1. Then this vector will be copied in these 2 commands, and then you have to print these 2 commands by this. Then this will be printed. Similarly, vector addition is there. 2 vectors can be added using this command. This is for 2 element. This is for 3 element. Then vector subtraction. So for this line you have to write this much. So this line will be printed. Then scalar vector product, that is product of a scalar and a vector. So one has to be careful about this syntax. Scalar is written within curly bracket. You see, scalar is written within curly bracket, whereas vector is written within round bracket. Otherwise, you will get an error. So this is written like this. Then scalar product or dot product of 2 vectors can be calculated like this. So here, for example, scalar product, dot product is calculated like this here. Then it calculates the norm also, vector norm also calculated. Okay, 3 square plus 4 square is 25, and then square root, that is 5. Then cross product is also calculated like this. Then you need vectors. Now whenever divisions come into picture, you have to sacrifice the accuracy. So here this is some kind of a lacuna, and it is always the case in computers. Whenever there is a division, you can't expect accurate results. So then comes the matrix operation. My interest lies here. So if you want to write this matrix, then you have to write this much. Matrix copy this much and this. Now what is the advantage of doing writing like this? You could have said that begin matrix directly. I can write the elements here and then get this matrix. That's true, but then this is dynamic. Dynamic, I'll tell you later on. Here of course you will not understand if I say if you change here 1 to any other element, it will be changed. So same thing here also. It will be, if you write 1 minus 1 2 here and change 1 from here, it will change here. But I'll come to that later, just a minute. So then transpose of a matrix is calculated by these commands, and if you download the complete document you can read it. then matrix addition, matrix subtraction. So you see this much command you have to write. Then comes scalar matrix product of a scalar and a matrix, that also can be done here. Then matrix vector product. So a matrix and vector is treated as a column vector. This vector is treated as column vector, so column matrix rather. So this way this is calculated. And then product of two square matrices is calculated by this command. By the way, this calculator package primarily deals with square matrices only, and of course these column vectors. Okay, column vectors multiplied on the right side of the square matrix. Okay, then determinant it calculates, and that's all. Of course it calculates the inverse also, but then again you don't get the accurate result because of involvement of division. Now I have designed some shortcut commands so that the matrix entry becomes quite easy. So in this section we discussed that an elegant method for writing matrices having at most 3 rows or columns. So how it is done? See, usually a matrix 3, 4, 9, -1 is entered into the system by writing this command. Okay, and the 3 by 3 matrix is entered using this command. But from now on, using our shortcut method, for 3491 simply type this much slash within $/sqmat, then 3, 4 semicolon 9, 1. That means row elements are separated by comma, and each rows are separated from the other row by a semicolon. So change of row is denoted by semicolon, and row elements are separated by comma. So this is the syntax you have to follow. Similarly here also same thing, don't have to write anything extra, just row elements you write separating them by comma, and then each row has to be separated by semicolon, then comes the second row, then again semicolon, then comes the third row. So if you like write only this much, this will be printed. So this is one shortcut. Similarly determinant, I have shown in those pages. Determinant command was also quite lengthy, but here you have to write only det-met, and then as usual row elements are separated by comma, and each row is separated. Different rows are written separately by this semicolon. Then det-met of this will be by this command, will be written by this command. Row vectors are written using row-met. So 3 element vector will be written. So here there is no semicolon because that's one row. And here column vectors will be written like this, even though there are one column, but then one can say that there are 2 rows, but then you don't have to use semicolon, you can just use comma only. So this is an exception for column vectors. So in column vectors, if you go down, here don't have to write semicolon give you error, you have to write comma. So row vector and column vector both are comma, whereas if matrix are not, a matrix is not a row vector or a column vector, then you have to use semicolon. So this you have to remember. And so for column vector command is colmat. Okay. Then matrix operations. So in first of all, how does calculator package do calculation? We'll explain that first, and then I'll explain how we have designed a shortcut method to do all this thing. So to begin with, in your main text file, this line has to be written, use package calculator. So this is essential line. Then suppose you want to calculate the determinant of this matrix, and then what happens, you have to write this much command, then it will print the determinant along with the value. So this command, determinant command, calculates the value and deposits it in the datfval command, and then you just write datfval, it will print 1. So the now advantage of this is, suppose I change these matrix elements, the determinant elements here, any or all the elements, if you change, this value will be changed automatically. You don't have to bother for the value here. I'll show you in the text file how it is done. Similarly, transpose of a matrix is computed using this command. So then this one will be written like this. So again, if you change anything in this line here, just in one place you change anything, this result will be changed, and of course this entry also will be changed. Then addition of these two square matrices is done like this using these commands. So again, if you change anything here, this result will be changed here automatically. This is the calculator package, activity of calculator package. So this matrix is subtracted from this matrix using this much command. Okay, so a lot of things you have to write. Then this will be computed here. So again, if you change these matrix entries, then all these entries will change, even the results also will be changed automatically. You have to just change these matrix entries, don't have to worry about the result. Result will be computed automatically. Here for this one also, these are the commands, quite a few of them, and then this will be computed automatically. Product of a scalar, say by 15 into this is how much, so it will also be computed automatically here. And if you change these entries or the value of the scalar, then this value also will be changed automatically. Then matrix product of this. Now this matrix product of this is just a product of matrix and a vector. So that is why command is matrix vector product. This command is given by calculator package. So it will be done like this. Now what happens? It may be mentioned here that the calculator package primarily deals with square matrices only, and of course vectors, which may be considered as row or column matrices. But taking Q from the item 6 above, that means from here, that a matrix and a column matrix can be multiplied in using calculator package. So if you take Q from here and then do little bit of manipulation using our shortcut method, little bit of manipulation, then this these two matrices also can be multiplied. This is square matrix, but this is not square, having 2 rows and 3 columns. And for that, command is, first of all, you copy this matrix, and this matrix you have to treat it as combination of two things. One is a square matrix, 5 minus 2 4 3, and another is a column matrix, 7 minus 9, which we call vector in the language of calculator. Okay, 7 comma 9. Then matrix product of this with this is calculated, then matrix vector product of this with this is calculated, and then these two columns are one column matrix and a square matrix are juxtaposed with each other using this command, juxcol. I call it juxcol. That means a column is juxtaposed with a row matrix here. So this we have developed. We have defined this command. So you just after this multiplication, this is square matrix, and this one is juxtaposition of this square matrix and 7 comma 9. This one is again juxtaposition. There are two juxcol commands. One is here for this one, and another is here for this one. Okay, so this is little bit of manipulation you can do. Then similarly, this one also, it can be multiplied this with this vector and this with again with this vector, and then these two columns are again written like this. Using rows are written like using this rowmat command, okay, which I have already told you earlier. The product of this, again this is a 3 by 3 matrix, but this is a 3 by 2 matrix. So again little bit of manipulation, and then finally this again that juxtaposition of two columns. These two columns are juxtaposed. So this juxcol command does two things. It juxtaposes a column with a matrix, and it also juxtaposes two columns. So here it has juxtaposed two columns. Same command, just depending on whether there is a semicolon involved or only commas, it will do the job. Okay. Now suppose with these commands we want to prepare a problem set on matrix operation. So a problem set will look like this. For example, it looks like this one. For matrix A and B, compute the sum. So this will be computed. So for this, let us now go to our text file. So I go to this. Yeah. So which one? Yeah, this one. So you see, sorry, this is not the one. I think, yeah, this is the one. So this matrix is 1, 2, 3, 1, 1, 0, and minus 1, 1, 2, this one, and B matrix is this one, 2, 1, 0, 1 minus 2. Yeah, so this is the one. Now this much command you have to write only for writing this line. So of course this is disadvantageous, that's why I have made this video. But let us see what is the advantage at least of this thing. So now let us see, suppose I make this 3 as minus 3. I change it here. So this first entry here I have changed it to minus 3. And so this will become minus 3. This will become, this is 0. So this will be minus 3 automatically. Okay, so I'll compile it and just see here. Oh, it has gone down because of this length problem. Anyway, I increase its this thing little bit, say 2.5 inch. I believe it will work now. Yeah. So you see this it has become minus 3. So but this is not a very good change. So let us now change this one to say 12. So the last entry, this one I have made it 12. So I expect this also should change. So let us see, I compile it. So this has become 12, and you see this has become 13. This is 12 plus 1, and automatically it is given 13. Okay. So similarly, one can do this for this minus A minus B, this much comma thing you have to write, and you have to write. So here, for example, if I write all say 0, 0, 0, the first row I have made completely 0, and let us see what happens. This result, just watch this result. So I compile it here. See, this has changed automatically. So this calculator, the most interesting part is the product. So here for these two matrix is the product. So this is matrix vector product. So here, for example, this product. So again, suppose I make this is matrix vector product. Which one is this one? Matrix product. This one, 5, 1. Yeah. So let us make this minus 1, 1, 2 So let us make this column, this row identical. -1. I write it -1, comma, -1, comma 1, comma 2. Oh, sorry. 1, comma 2. So these two rows are identical. So I expect 0 here. Where is the product gone? Product is here. Yeah, product is here. This is the matrix I am looking at. So if I compile it, what I have changed and where? I have changed -1, 1, -1. Okay. So no, I was thinking something else. Okay, this is -1, 1, 2. This is -1. So you see this has changed. So what was the original thing? Original was my press Ctrl Z. Yeah, it was 1, -2, 3. So that is why it is getting shifted. Sorry. So now this is different. Okay. Similarly, so like that, all these thing, say for example, this is scalar product. Let me see. Okay, this is the determinant. Yeah, this is one actually. I had in mind this one. If I make two rows identical here, where is the determinant? Determinant. Yeah, yeah, this is the determinant question. 1, -2, 3, 1, 1, 5, 1 minus. Yeah. So here, if you make two rows identical, then the result should be 0. So I make it -1, comma 1, and then -2, and see the determinant. Now it gets shifted by the time I write it. Yeah, okay, it got shifted, but doesn't matter. Let's see here. So this one will change, this one will change, the answer will be 0. Let's see it works or not. Yeah, so you see answer is 0. If two rows are identical, answer is 0. So the 0 is computed automatically. Anyway, so all these, so what I am saying is that it does things automatically, but then look at the enormous amount of commands you have to write to achieve all these things. So that is why, so all these things are there. You can check it yourself also. But this is what actually I want to tell you again. Okay, which one? So although we have already discussed a lot in this video, the main purpose of this video starts only now. We have designed some way out to include all matrices, square and non-square, having at most 3 rows and 3 columns. This is illustrated in the next section, again with the help of a problem set. All the dirty works have been included in a separate file, which you may download using the link given in the description of this video and include in your main text file as a preamble using the command, this particular command you write, because this dirty file name is preamble -matrix.tex. And needless to mention here that your main text file must use the exam class file, and which is actually built upon article class file. Whatever you can do with article class file, you can also do with exam class file, and plus something more. So now this is an extremely user-friendly method of using matrix operation in LaTeX. So this is our work here. So the problem set in the previous section looks quite nice, but it takes a lot of time and effort to prepare it. Here we prepare a larger problem set with much less effort as follows. Now this is a easy to type set, problem set. It is very easy to type. So the problem set, the outcome looks almost the same here two matrices are there, and you have to compute sum, difference and product. So it is computed in 3 lines like this. Okay, so let us see, go to text file and see what is happening here. Yeah. So so we are here now. Now for this particular question, actually there are 3 questions here. You have to sum it, you have to make, calculate the difference and the product also. You have to simply write this one, just one command, in capital letters, mat AD, and then you write the matrix elements. Row elements are separated by comma and rows are separated by semicolon. So I told you earlier also. So using that you just write. So mat add, this command has 2 arguments. First argument takes first matrix, second argument takes second matrix. And then it gives you 2 things. It gives you first mat, one matrix, the first matrix will be stored in first mat, second matrix will be stored in this command second mat. And you can use it in this line. For A equal to first mat, then this will be printed. For B equal and B equal to this, compute the sum. You can see here this one. So first of all, in the first box, sum is calculated. So A plus B is equal to, this is first mat plus second mat, and this is final mat. So final mat will be there. So this method has done 2 things. One is that it has stored the first matrix in the first mat, second matrix in the second mat, and also calculated this. Now if you want to calculate the minus, and if you simply write A minus B equal to this command, then it will, here it will write alright A minus B, but here it will write A plus B, the value of A plus B. So to overcome that, you have to write mat sub command. Otherwise this first mat and second mat and final mat will be taken from this matted command. But if you write mat sub command, this also will generate first mat, second mat. Of course this first mat and this first mat are same, but this final result and this final mat are not same. Then comes this mat product for this product. So again you write mat product and this. Now here you see, let us see mat product. So if I, in the mat product, if I write something, say I make some changes. So I put minus sign here, say minus here and minus here. Then see what happens. Just in one place I have changed it in the mat product, and then you see. So again it has become long, so you make it 2 inch maybe. So you see this all these minus, it has come, and this product is calculated automatically. Now here you see one thing, the original question, this has not changed. This is because this method, this is taken by this method command, and only this final one is taken by this matprod command here. So this is correctly printed. This first mat is taken by this, but this first mat is this. Okay. But if you have a single question type, so this is similar, the next question is similar, so you can safely avoid it. All these things I have included in a text file which you can download, so don't have to memorize all these commands. You can easily get them. I'll give you everything. Now for example here this one, it calculates only addition. So here if you write minus 2, minus 3, so suppose it you write minus 2 and this one I make minus 1. So this is 2 I make minus 2, this one I make minus 1. And then you see everything will be changed here. See, this is minus and this result is also changed automatically. So this thing is there. Okay. Then for subtraction mat sub, for computing the transpose, see how small the command is. Just trmat and then write the matrix, and then for A equal to this, compute the transpose, and answer is AT first mat first met, then this hook T, so that will give you this transpose, this T here, first met, hook, this T, the transpose, and then final met, so this result will be there. Okay, and then comes this, this is also there. Okay, and then you see all kinds of matrix product. This is 3 rows, 2 columns, 2 rows, 1 column, but you don't have to worry. Simply write matprod and write the matrix entries. Don't have to mention how many rows, how many columns. This comma and semicolon will take care of it, and answers will be automatically printed. So in the previous problem set, it was so difficult to write, so much of things you have to write, but here you have to write only just one line, then this will be printed. Okay, and by the way, another thing I show you, here only I can show you, if you write a command called no print answers, and then you see all these answers will go. So this is all the answers from now on are vanished. Earlier answers are there, but the point from where this no print answers are there, this is blank. So now this is a question paper, you and ask your student to fill it up, and then later on you remove this and then check that the answer has come back. Okay, and the same thing you can do from here also. Here also, if you remove these answers from here, then also all the answers will vanish. Then no print answer command is not required. So if you remove this and then compile this, then you can see all the answers are gone. Where is the problem set? Whenever, yeah. So here is the problem set. This is the first problem set. See, all the answers have vanished. So all the answers have vanished. Second problem set, all the answers have vanished. And you have to get back your answers, simply do this and compile it. Of course, here you can put a percentage sign and then again compile it. This will come back, yeah. So, and see all kinds of metrics it has taken care of. 2 rows, 3 rows, 1 row, 1 column. Okay, all kinds of things, but the command is same, matprod command. Scalar product command is sc matprod. So, and lambda is the scalar. For scalar, you have to write the command sclr, and then first mat and final mat. These two commands will do. So this text file will be there for download. You can download it, and you can get these commands from there. Determinant will be calculated by detmat. Now all this thing, and here again, as I said, if you change anything from here, suppose here I change this one. This is first detmat. Which one is first? This one. Okay, 2 by 2. So let us make it this also -1, 1. So -1, 1. So answer should be 0, right? Where is my determinant? Yeah. So answer is here. So see, it has become 0. So this is the advantage. So you can supply different question paper to different students by simply changing the entries here, and you don't have to wait for the result. Result will be computed by LaTeX program. Now the last thing in this video is, suppose while typing you make some mistake. As I said, you must have at most 3 rows and 3 columns. and determinant must be for square matrix. Metric addition, two matrices must be of same type, and at the same type number of rows and number of columns should not exceed 3. Suppose you violate these rules, then you get some warning message. For example, here this datmat command, this is not a square matrix, so it is written undefined, not a square matrix. Okay. Then in the metric addition method, there are actually more than three rows or 3 columns. So it has written not allowed more than 3 rows columns. So likewise, this product also, this is 2 by 2 matrix, and product, these two are not compatible for product. So it has written undefined and incompatible matrices. So while typing, if you make mistake and compile your file, then you don't have to worry, you will get some warning message. So I hope this will be useful for you. Use it and tell me if you find any mistake in the program and how you feel it. Write in the comment box. People simply download my files and forget, they don't respond, but I am always available for your questions, for answering your questions. So please do comment in the comment box. Thanks for watching.